All right, hello everyone. So today we have the following. Find the following limit if it exists. The limit as x approaches 64. Quantity x minus 64 divided by the quantity root x minus 8. And this limit has an indeterminate form of 0 over 0. So as x approaches 64, both the numerator and denominator would approach 64 because 64 minus 64 is what the numerator looks like, which is 0, and root 64 minus 8 is what the denominator looks like, or 8 minus 8, 0. And this indeterminate form is a form for which you need to do a little more work to figure out what the limit is equal to, if it exists. A lot of people say, oh, it's undefined because you're dividing by 0. But that notation doesn't mean that you are dividing by 0. All it means is that you're approaching the numerator and denominator, both the numerator and denominator approaching 0. So we don't add to the confusion. A lot of time we use that quotation notation around it to say kind of like 0 over 0. Well, anyways, so I don't know what this limit is equal to, so I'd like to try something else, so maybe algebra. That's what the focus of the video is today. So when you have a radical and a binomial, which is what we have here with that denominator, you have a binomial with that radical x, you're going to try this trick which is multiply by the conjugate. And the conjugate, if you have a binomial, so if you have a minus b, the conjugate is simply a plus b. So the sign in the middle between the two terms is switched, okay? So that's what we're going to be working with. And what we start off with when you have a binomial with a radical, with a limit, is you're going to multiply by the conjugate of root x minus 8, which would be root x plus 8 on both the numerator and denominator. You do it to both the numerator and denominator because if you did not, you'd be changing the problem around, okay? So then we went ahead and did that, but obviously we want to do some simplification. The simplification will be done primarily with that denominator. Root x minus 8 times root x plus 8. That becomes root x squared minus 8 squared, okay? How am I getting that? I'm using the difference of squares. Difference of squares says that if you have a minus b times a plus b, it's equal to a squared minus b squared. And we apply that rule here just so we can get rid of that radical, okay, which we'll see in a second, from that denominator. So we continue on with this problem. We get the limit as x approaches 64, and root x squared becomes an x, 8 squared is 64, times x minus 64 times root x plus 8. And I'm not going to touch that numerator. Why not? Because it's not in the sense of like touch it. I'm not going to FOIL or anything, because you won't be able to do the next step, which is cancel things out. So in general, when you're multiplying a fraction, both the numerator and denominator, by a conjugate, you only multiply out the part where you have the difference of squares. That's it. And the x minus 64 cancels, and all of this is now equivalent to taking this limit, and if you plug 64 in, as x approaches 64, excuse me, you get a 16, and that is what your limit would equal, okay? So that is the trick to use here, is to multiply by the conjugate when you have a binomial with a radical. So I'll be making another video going over other techniques for indeterminate form 0 over 0, and yeah, thank you for watching.